So hi everybody, here's Permutations Part 2, a formula for permutations. So the way I want to do this is I want to do an example first. Our example, I have written down the things right below, and it says 20 students need 3 officers. Okay, so they're in a group or a club and they need 3 officers. And so the way they're going to do it is they're just going to pick people randomly out of a hat or something like that. So the first one picked is a president, the second one picked will be the vice president, and the third one picked will be the treasurer. And the question is, in how many ways can the officers be chosen? So the first thing you have to be aware of is there's an order here. We're going to have choices for the first person picked, choices for the second person picked, and a number of choices for the third person picked. And the answer then is there are 20 choices to be president, and then once you have the president, you only have 19 choices left for vice president, and once you pick the vice president, you only have 18 choices left for that one. And if we multiply these numbers, then we would end up with our solution for the number of ways the officials can be chosen. I do have my handy dandy calculator here, so it is 20 times 19 times 18, and that is 6,840 possible officer groups. Okay, so let's pause that and we'll set up the next slide, and then you can we'll show you how this leads to a formula. So what we see here is right here is our original problem, okay, and right here I have written the rest of that if it was a permutation from 20 all the way down to 1. So why did I do that, and why did I divide by that? Well, normally, based on what we did before, we'd always have 5 items and we'd say, well, in how many ways can those 5 items be chosen? And that would be all 5, or in this case, all 20. But the reason I'm showing this box here is that we don't have that. We only chose 3 people to be the officers, and so we essentially forgot about the other 17 in the multiplication. And a good way to illustrate that mathematically is to make it into a 1, or in other words, a division problem. And so this in the box is equal to 1. And so if we look at that, then we can say that the numerator is really a permutation of 20 things, and the denominator is a permutation of 17 things. And what we did is we chose 3 out of those 20. And so the way you would write that as formula is a permutation of 20 things, choose 3 at a time, and that would be equal to 20 factorial over 20 minus 3 factorial, which would equal 20 factorial over 17 factorial, which is exactly what I have written in these 2 fractions. And so the way we write the formula for a permutation is right here, and then this is how that gets interpreted. In general, the permutation of n things taken r at a time is equal to n factorial over n minus r factorial. And that's the formula that we want to use. And now you can also see that if I come back to this problem, then this gets written as I've written it up above in blue, and the 17 factorial cancels, and you just get 20 times 19 times 18. So a part of your assignment will be problem numbers 33 through 40, where you have to practice these permutation techniques. One other issue I want to tell you about is sometimes you'll have something like this, a permutation of 10 things taken 10 at a time. Well, that's equal to 10 factorial over 10 minus 10 factorial, which is equal to 10 factorial over 0 factorial. And the question is, what's 0 factorial? Is that just 0? Well, it turns out in algebra there is a function that represents the factorials, and 0 factorial is actually equal to 1. So this expression is really 10 factorial divided by 1, or just whatever 10 factorial is equal to. Okay? So you want to keep that in mind, that 0 factorial is always equal to 1. Okay? It's not 0. If you're really interested, I'll look up where that is mathematically and I'll show it to you. Okay. Next question will be some practice problems. So we have our two example problems here. The first one is, I want you to take a permutation of 8 things, taken 5 at a time, and figure that out in factorials as I did on the previous slide. The second problem is we have a situation where we have 9 bands who have volunteered for a concert, a benefit concert, but there's only time for 5 of those bands to actually play. So the question is, how many lineups are possible for the concert? So go ahead, pause the video, and take a moment to do each of those problems. Well, I am back, and as you can see, I've written out the solution to the problem in blue. 8 factorial over 8 minus 5 factorial, which is 8 factorial over 3 factorial. The 3 factorial cancels, and therefore you have 8 times 7 times 6 times 5 times 4, which is equal to 6720. The 9 bands, you only choose 5 to play, is a permutation of 9 choose 5. And you can see that as you work through the work, you end up with 9 factorial over 4 factorial, which multiplies out to this after you cancel the 4 factorial, and your final answer is 50,120. And so a special question tomorrow is, somebody should ask this, how do I do this on a calculator? And why do I want you to ask that? Well, it turns out on a calculator there is the permutation formula, and I just want to show you how to enter that into the calculator. It'll simplify your calculations on a test and make things go a lot slower. But I will probably ask you to do them the long way as well on the test, but only once. Okay, that's all I have. Video done, and we'll see you tomorrow in class.